Welcome to your strategic preparation for the Senior AI Product Manager role at OpenAI. You're about to master the technical architecture that powers modern AI applications, understand how to build trustworthy AI systems for government use, and align your product thinking with OpenAI's mission. This isn't just theory. This is the exact knowledge framework you'll need to demonstrate technical depth and strategic thinking in your interview. Let's transform your government sector experience into the language of cutting-edge AI product management. Your learning journey has three strategic modules. First, we'll deconstruct the modern AI agent stack, from LLMs and vector databases to orchestration frameworks like LangChain. You'll understand how these components work together to create intelligent applications. Second, we'll explore building trustworthy AI for government, covering fairness, transparency, accountability, and human-in-the-loop systems that are essential for public sector deployment. Finally, we'll master strategic product thinking at OpenAI, learning how to translate government needs into technical requirements while communicating complex AI concepts to stakeholders. By the end, you'll speak the technical language of AI product management with the strategic mindset OpenAI values. An AI agent is far more than a chatbot. It's an intelligent system that can reason, plan, and use tools to accomplish complex tasks. Think of it as a digital colleague that can analyze documents, make decisions, and execute actions autonomously. In government operations like logistics coordination, policy analysis, or citizen service delivery, agents can process vast amounts of information, identify patterns, and recommend actions while maintaining the ability to explain their reasoning. This capability to break down complex problems and execute multi-step solutions makes AI agents transformative for public sector challenges that require both scale and precision. The AI agent stack is best understood as a four-layer architecture similar to a web application stack. At the foundation, we have the data layer, where vector databases store and retrieve contextual information. Above that sits the orchestration layer, powered by frameworks like LangChain that coordinate between components. The model layer contains the large language models that provide reasoning capabilities. Think GPT-4 or Claude. Finally, the application layer presents the user interface and manages interactions. These layers work together seamlessly. A user request flows down through the application, gets orchestrated by LangChain, leverages the LLM for reasoning, and draws on vector databases for relevant context. Understanding this stack is crucial for designing scalable AI products. The large language model serves as the reasoning engine, the brain of your AI agent. It processes natural language, understands context and intent, and generates human-like responses based on patterns learned from vast datasets. When a user asks a complex question, the LLM breaks it down, considers multiple angles, and formulates a coherent response. The choice of model, whether GPT-4, Claude, or an open-source alternative, becomes a critical product decision that affects capabilities, costs, and compliance requirements. For government applications, factors like data residency, security clearances, and performance benchmarks all influence which LLM brain powers your agent. AI agents need memory to be truly effective, and this comes in two forms. Short-term memory is the context window, the immediate conversation or task the LLM can hold in its attention, typically ranging from 8K to 200K tokens depending on the model. But for persistent knowledge and institutional memory, agents rely on long-term memory systems. This is where vector databases become crucial. They store information as mathematical representations called embeddings, allowing agents to retrieve relevant context from vast knowledge bases instantly. Imagine a policy analysis agent that can remember every regulation, precedent, and case study. That's the power of combining short-term reasoning with long-term memory through vector storage. Planning and task decomposition transform AI agents from reactive chatbots into proactive problem solvers. When given a complex goal, like summarize recent cybersecurity threats affecting federal agencies, an agent must break this into smaller, executable steps, identify relevant sources, search for recent incidents, categorize threat types, analyze impact patterns, and synthesize findings into a coherent summary. This process uses frameworks like React Reason plus Act, where the agent alternates between reasoning about what to do next and taking specific actions. The planning capability enables agents to handle multi-step workflows that mirror how human experts approach complex analytical tasks, making them invaluable for government operations requiring systematic analysis. Orchestration frameworks are the nervous system of AI agents, coordinating complex interactions between models, tools, and data sources. LangChain and Llama Index are the leading frameworks that simplify building sophisticated agentic workflows. Think of them as the conductor of an orchestra. They ensure each component plays its part at the right time. LangChain excels at chaining together multiple LLM calls, routing requests to appropriate tools, and managing data flow between components. It handles the complex logic of when to search a database, when to call an external API, and when to synthesize information. Without orchestration frameworks, developers would need to manually code every interaction, making AI agent development exponentially more complex and error-prone. Here's LangChain orchestration in action. A user asks, "What's the latest on federal cybersecurity budgets?" LangChain receives this query and routes it through a decision tree. First, it determines this requires both current news and official budget data. The framework calls a web search API to find recent articles, then queries a government database for official budget figures. Each API call returns raw data that gets fed to the LLM for analysis and synthesis. LangChain manages the entire workflow, routing the initial query, coordinating multiple data sources, handling API responses, and ensuring the LLM has all necessary context for a comprehensive answer. The final response combines real-time news with official data delivered as a coherent analysis. This seamless orchestration transforms a simple question into a sophisticated research process. Vector databases are the foundation of intelligent memory for AI agents. Unlike traditional databases that store exact text matches, vector databases store information as mathematical representations called embeddings, essentially converting meaning into numbers. When an agent needs information, it doesn't search for exact keywords, it searches for semantic meaning. Ask about budget constraints, and it might retrieve documents mentioning financial limitations or funding restrictions because the concepts are mathematically similar. This semantic search capability is essential for giving agents domain-specific expertise. Instead of training a new model on government data, you can load policies, regulations, and procedures into a vector database, instantly giving your agent access to institutional knowledge while maintaining data security and control. Consider a policy document analysis agent for the Department of Homeland Security. The agency has thousands of policy documents, regulations, and procedural manuals scattered across different systems. Traditional keyword search would require analysts to know exact terminology and manually review multiple documents. With a vector database, all policy documents are converted to embeddings and stored semantically. When an analyst asks, "What are the protocols for cross-border data sharing?" the agent instantly identifies relevant documents, even if they use different terms like international information exchange or transnational data coordination. The vector database returns the most semantically relevant sections, the LLM synthesizes the information, and the analyst gets a comprehensive answer in seconds instead of hours. This transforms policy research from manual document hunting into intelligent knowledge retrieval. Now, let's see the complete AI agent stack in action. A user submits a request through the application layer, perhaps asking for a security briefing on emerging threats. LangChain in the orchestration layer receives this request and creates an execution plan, search recent threat intelligence, query historical incident data, and analyze patterns. The framework coordinates multiple tool calls, a web search API for current threats, a vector database query for similar past incidents, and document analysis tools for detailed reports. Each tool returns data to the model layer, where GPT-4 processes and synthesizes the information. The LLM combines real-time intelligence with historical context, identifies patterns, and generates a comprehensive briefing. The final output flows back through the application layer to the user. This seamless integration of reasoning, memory, planning, and orchestration creates truly intelligent government applications. You now have a deep understanding of the modern AI agent stack, from the LLM brain that provides reasoning to vector databases that serve as long-term memory to orchestration frameworks like LangChain that coordinate complex workflows. You can speak confidently about how these components work together to create intelligent applications that go far beyond simple chatbots. This technical foundation positions you to discuss AI architecture with the depth expected of a senior AI product manager. But with this power comes enormous responsibility. As we move to Module 2, we'll explore how to build these systems to be trustworthy and safe, a critical concern for any AI deployment in the public sector. In the public sector, AI decisions can directly impact citizens' rights, access to essential services, and public safety. A benefits determination system that's biased could deny deserving families assistance. A criminal justice risk assessment tool that lacks transparency could unfairly influence sentencing. A cybersecurity agent that acts without human oversight could escalate situations inappropriately. Trust is not a nice-to-have feature. It's the fundamental requirement that determines whether AI systems can be deployed responsibly in government. This aligns perfectly with OpenAI's core mission of ensuring AI benefits all of humanity. For government applications, trustworthy AI isn't just about compliance, it's about maintaining democratic values and public confidence in institutions. Fairness in AI starts with recognizing that bias can creep in at multiple points. Bias training data, algorithmic design choices, and human interaction patterns. For government applications, this means asking critical questions during product development: who might this system harm? What groups could be underrepresented in our data? How might our algorithm perpetuate existing inequalities? Technical mitigation involves dataset auditing, examining training data for demographic representation and outcome disparities. It includes algorithmic bias testing, measuring whether the system performs equally across different groups. Most importantly, it requires ongoing monitoring after deployment. A product manager's role is to build these fairness checks into the development process from day one, not as an afterthought. This proactive approach to bias mitigation is essential for maintaining public trust and legal compliance. Transparency and explainability are often confused, but they serve different purposes. Transparency means stakeholders understand how the system works, what data it uses, what algorithms it employs, and what its limitations are. Explainability means users understand why the system made a specific decision. Your loan application was denied because your debt-to-income ratio exceeds policy thresholds. For government AI, both are essential. Citizens have a right to understand the systems that affect them. Auditors need to verify compliance with regulations. Technical teams need to debug and improve performance. This requires building audit trails that track every decision, creating clear documentation about system capabilities and limitations, and developing explanation interfaces that translate complex AI reasoning into understandable language for different stakeholder groups. Accountability means establishing clear lines of responsibility for AI system outcomes. When an AI agent makes a mistake, denying a valid benefits claim, or missing a security threat, someone must be responsible for investigating, correcting, and preventing similar issues. This requires robust governance structures. Many government agencies establish ethical AI review boards that evaluate proposed AI systems before deployment. These boards include technical experts, domain specialists, and community representatives. They assess risks, approve safeguards, and monitor ongoing performance. Accountability also means creating processes for redress and appeal. Citizens affected by AI decisions need clear pathways to challenge outcomes and seek corrections. Product managers play a crucial role in designing these accountability mechanisms into the system architecture, not as external oversight, but as integral features that enable responsible operation. Technical guardrails provide automated safety checks that prevent harmful AI behavior. Input filtering examines user requests before they reach the AI model, blocking attempts at prompt injection, jailbreaking, or requests for harmful content. Output filtering reviews AI responses before delivery, ensuring they meet safety standards and don't contain inappropriate information. OpenAI's moderation API exemplifies this approach. It can detect and flag violent, sexual, hateful, or dangerous content in both inputs and outputs. For government applications, additional filters might check for classified information disclosure, policy compliance violations, or biased language. These guardrails operate in real time, providing immediate protection without human intervention. However, they're not foolproof. Sophisticated attacks can sometimes bypass filters. This is why guardrails work best as part of a layered security approach that includes human oversight and ongoing monitoring. Beyond content filtering, we must constrain what actions AI agents can perform. This applies the cybersecurity principle of least privilege to AI systems. Agents should have access only to the minimum tools and permissions necessary for their function. A document analysis agent might have read only access to file systems but cannot delete or modify files. A research agent might query databases but cannot update records. A customer service agent might access account information but cannot process financial transactions. For high-risk actions, agents require explicit confirmation before proceeding. This might involve asking users to confirm sensitive operations or escalating to human supervisors for approval. The goal is to prevent both accidental damage and malicious exploitation. Product managers must carefully design these permission boundaries, balancing agent effectiveness with safety requirements. Human in the loop represents the gold standard for AI safety, ensuring humans maintain meaningful control over AI systems. There are three main models. Human in the loop means humans actively participate in every decision, reviewing and approving AI recommendations before implementation. Human on the loop means humans supervise AI operations, monitoring for problems and intervening when necessary. Human out of the loop means full automation with humans only involved in system design and maintenance. For government applications, the stakes often demand human in the loop or human on the loop approaches. The product manager's role is crucial here, deciding where to place humans in the workflow. This isn't just a technical decision, it's a strategic choice that balances efficiency with accountability, speed with safety, and automation with human judgment. The goal is meaningful human control, not just human presence. Consider an AI-assisted benefits approval system for a state social services agency. Applications flow into the system where an AI agent analyzes eligibility based on income, family size, and other criteria. The agent classifies each application into three categories: standard approval for clear-cut eligible cases, denial for clearly ineligible applications, and needs reviews for complex or borderline situations. Here's the human in the loop design. All denial decisions require human review before notification, protecting citizens from AI errors. All needs review cases go to trained caseworkers for detailed evaluation. Only standard approval cases proceed automatically, but with audit trails for later review. This workflow reduces caseworker burden by 60% while maintaining human oversight for all negative decisions. Citizens maintain their right to appeal, and the system provides clear explanations for all decisions. This balances efficiency with accountability, the hallmark of trustworthy government AI. The justice system represents the ultimate test for trustworthy AI, where decisions can affect freedom, rights, and lives. A federal agency wanted to deploy AI to summarize complex legal documents for judicial review, reducing the time judges spend on case preparation. The challenge was immense. Legal documents contain nuanced language where context is crucial, bias could influence case outcomes, and absolute reliability is non negotiable. Any error could compromise justice. The stakes demanded a comprehensive approach to trustworthy AI that went beyond typical enterprise deployments. This case study demonstrates how to apply fairness, transparency, accountability, and human oversight principles when failure is not an option. The solution integrated every trustworthy AI principle we've discussed. For fairness, the team conducted extensive bias testing across case types, legal jurisdictions, and demographic factors, ensuring the AI didn't favor certain legal arguments or case characteristics. For transparency, they built comprehensive audit trails tracking every document processed, every summary generated, and every decision point. The system provided clear explanations of its summarization methodology and highlighted areas of uncertainty. For accountability, they established a legal AI review board including judges, attorneys, and AI ethics experts who evaluated system performance monthly. The technical implementation was equally rigorous. Input filtering prevented processing of inappropriate content. The agent was constrained to summarization only, no legal interpretation or recommendations. Most importantly, they implemented a robust human in the loop workflow where experienced attorneys validated a statistical sample of all summaries. The outcome exceeded expectations. 40% reduction in document review time, maintained accuracy standards, and enhanced judicial confidence in case preparation. You now understand the comprehensive framework for building trustworthy AI, from ethical principles like fairness, transparency, and accountability to technical implementations including guardrails, constraint permissions, and human in the loop workflows. You've seen how these aren't just compliance requirements, they're strategic advantages that enable better outcomes while maintaining public trust. The justice system case study demonstrates that trustworthy AI can simultaneously improve efficiency and safety when implemented thoughtfully. This expertise positions you to discuss AI safety and governance with the depth expected at OpenAI, where responsible AI development is core to the company's mission and competitive advantage. Now, let's explore how this thinking integrates with OpenAI's broader strategic approach. OpenAI's public sector strategy centers on providing secure, compliant AI tools that enhance government operations while upholding democratic values. Through initiatives like OpenAI for Government launched in 2024, the company delivers ChatGPT Enterprise and ChatGPT Gov in dedicated, secure environments designed for privacy-sensitive government use. Major partnerships include NASA, the National Institutes of Health, the Treasury Department, and a significant $200 million Department of Defense contract for administrative functions, data management, healthcare delivery, and cybersecurity applications. In the UK, OpenAI signed a formal memorandum of understanding with the government, committing to AI infrastructure investment and expanded research operations. The core mission remains ensuring AI benefits all of humanity, but the public sector approach emphasizes three key pillars: robust security and compliance frameworks, transparent governance with ethical oversight, and scalable solutions that maintain democratic accountability. This isn't just about selling software, it's about enabling government transformation while preserving public trust. Translating government needs into technical requirements is a core skill for AI product managers. The process follows a structured approach. Start with the government need expressed in mission terms. We need to reduce paperwork burden for veterans seeking disability benefits. Translate this into a user story that captures the human workflow. As a claims processor, I want to automatically extract key information from medical documents so I can focus on complex eligibility decisions rather than data entry. Finally, convert this to technical requirements using your AI stack knowledge. Develop an agent using the Assistance API with document parsing capabilities integrated with a vector database containing VA regulations and precedent decisions. The key is maintaining traceability. Every technical decision should connect back to the original government need. Here's the translation process for a more complex scenario. Government need: proactively defend against evolving cyber threats to federal infrastructure. This broad mission requires deeper analysis to identify the specific user workflow. User story: as a security analyst at a federal agency, I want to be alerted to novel attack patterns in real time so I can investigate potential threats before they escalate into successful breaches. Now we can define technical requirements. Build an AI agent that continuously monitors network logs using streaming data processing, maintains a vector database of known attack signatures and threat intelligence, employs the LLM's pattern recognition capabilities to identify anomalies that don't match existing signatures, and implements a human-in-the-loop workflow where high-confidence alerts trigger immediate analyst notification, while medium confidence, the agent must operate within strict security boundaries. Read-only access to logs, no network modification capabilities, and all alerts include explainable reasoning for analyst validation. This specification directly traces from cyber defense mission to actionable technical architecture. Communicating complex AI concepts to non-technical stakeholders requires strategic simplification without losing accuracy. Use familiar analogies. Describe the AI agent stack as a team of specialists, where each member has expertise in different areas. One handles memory, another coordinates tasks, and the brain makes decisions based on all available information. Focus on outcomes rather than mechanisms. Instead of explaining vector embeddings, say the system can instantly find relevant information from thousands of documents, like having a research assistant who has read everything and remembers exactly what you need. Emphasize measurable value. This approach reduces document review time by 40% while maintaining accuracy standards. Be transparent about limitations. OpenAI's product philosophy rests on 4 foundational pillars that shape every strategic decision. First, safety and human-centric design are paramount. AI systems must enhance human capabilities rather than replace human judgment, particularly in high-stakes government applications. Second, deep technical curiosity and excellence are required. Product managers must understand the technology deeply enough to make informed trade-offs between capability, safety, and performance. Third, products must succeed in high compliance, high-stakes environments. Government deployments demand robust security, audit trails, and regulatory alignment that exceed typical enterprise requirements. Fourth, every product decision must balance security, scalability, and societal benefit. Optimizing for one dimension while neglecting others leads to unsustainable solutions. This philosophy manifests in product features like comprehensive audit logging, explainable AI outputs, granular permission controls, and human oversight workflows. It's not enough to build powerful AI. OpenAI builds AI that government agencies can trust, audit, and deploy responsibly at scale while serving the public interest. Your interview preparation should focus on 3 key areas that demonstrate both technical depth and strategic thinking. First, be prepared for architectural discussions. Walk me through the architecture of an AI application you've built or would build for government use. Draw from Module 1 to discuss the agent stack, explaining how LLMs, vector databases, and orchestration frameworks work together while incorporating government-specific requirements like security and compliance. Second, expect safety and governance questions. How would you ensure the safe deployment of an AI system in a high-stakes government setting? Use Module 2 principles: fairness, transparency, accountability, and describe specific technical implementations like guardrails and human-in-the-loop workflows. Third, anticipate strategic alignment questions. Tell us about a time you translated a complex stakeholder need into a technical specification. Apply Module 3 frameworks to show how you connect government missions to user stories to technical requirements. Practice articulating these concepts clearly and confidently. Your ability to bridge technical and strategic thinking is what distinguishes senior product managers. You now think like a senior AI product manager at OpenAI. You can translate public sector needs into technical reality using the AI agent stack, align with the company's mission of responsible AI development, and communicate complex ideas with clarity to both technical and non-technical stakeholders. You understand that Government AI requires exceeding typical enterprise standards for safety, compliance, and accountability. Most importantly, you can connect technical capabilities to strategic outcomes, the hallmark of senior product leadership. This comprehensive understanding of technology, safety, and strategy positions you to excel in your OpenAI interview. Now, let's consolidate your knowledge and prepare you for sustained success in the role. Let's consolidate your transformation. First, you've mastered the AI agent stack. Understanding how LLMs provide reasoning, vector databases enable memory, orchestration frameworks like LangChain coordinate workflows, and all layers integrate to create intelligent applications that go far beyond simple chatbots. Second, you've internalized trustworthy AI as a strategic advantage, not a compliance burden. Knowing how fairness, transparency, accountability, and human in the loop systems create safer, more reliable government AI deployments. Third, you've learned to think strategically like OpenAI, translating government missions into technical requirements, communicating complex concepts clearly, and aligning product decisions with the company's philosophy of responsible AI development. You're no longer just an experienced product manager. You're an AI product leader ready for the challenges and opportunities at the forefront of government AI transformation. You are no longer just an experienced product manager with government background. You are an experienced product manager who speaks the technical and strategic language of a leading AI company. When interviewers ask about AI architecture, you'll confidently discuss agent stacks, vector databases, and orchestration frameworks. When they probe about AI safety, you'll articulate trustworthy AI principles and their technical implementations. When they explore strategic thinking, you'll demonstrate how to translate government needs into technical specifications aligned with OpenAI's mission. This knowledge framework gives you the vocabulary, concepts, and strategic perspective to engage as a peer, not just a candidate. Use this foundation to structure your interview responses, demonstrate your readiness for day one impact, and show that you understand both the technical possibilities and responsibilities of AI in government. You're prepared to contribute immediately to OpenAI's public sector mission. Here's your immediate next step. Take one public sector problem you're familiar with from your government experience. On a single page, draft an AI product proposal that demonstrates your new expertise. Outline the AI agent stack architecture you'd use, detail your trustworthy AI implementation plan, including specific guardrails and human-in-the-loop workflows, and explain how your solution aligns with OpenAI's mission of responsible AI development. Practice articulating this proposal clearly and confidently. Imagine presenting it to OpenAI's product leadership. This exercise will consolidate your learning and give you a concrete example to reference in your interview. You have the knowledge. You have the framework. Now apply it. Good luck with your interview. You're ready to make a significant impact.